In today's video, here is a nice and quicker problem. It's coming from Bulgarian Mathematical Olympiad edition 2007. Here is the following setup. So our goal, we are going to solve this following equation. We have 8 is raised to the x as an exponent minus 2 to the x all over 6 to the x minus 3 to the x. The whole thing equals number 2. Okay. We are simply going to solve this equation in integers. Before we move on to the solution, I would recommend to give the hand to this problem prior to solution. By the way, don't forget to hit the subscribe button and support the channel. So let's jump into the solution to see what's giving us. So I'm simply going to factor out this numerator because we have e to the x is going to be written on the form of 2 to the 3x. Okay, so I get here 2 to the 3x minus 2 to the x all over 6 to the x minus 3 to the x. So I'm going to make 2 to the x as a common factor here. So I'll have the following: 2 to the x factor to the 2x minus number 1 all over. I'm going to take 3 to the x as a common factor. So we'll have the following: have 3 to the x factor. 6 to the x is going to be factorized as 2 is multiplied by 3, which means I have here 2 to the x minus number 1. Also, I get a difference of 2 squares in this one, so I'm going to factor this one as well. So I get here, so I will have the following: I get 2 to the x factor 2 to the x minus 1 factor 2 to the x plus number 1, which equals 2 is multiplied by 3 to the x factor 2 to the x minus number 1. Okay, be careful here. In order to divide both sides by 2 to the x minus number 1, make sure x must be different than 0. So in the other word, x must be strictly superior than 0, because if x equals 0 here, it will have this one 0, because it will have 1 minus 1. And also here, if you divide both sides by number 2 with x equals 0, I get number 1. So 1 divided by 2, it's impossible. Okay, so in order to divide both sides by in order to consider this condition, so x must be superior to number 1. Okay, that's simplifying this one and this one. I will be left with 2 to the x minus number 1, and I will be left with 2 to the x plus number 1, which equals 3 to the x. Okay, because I'm already simplified this one and this one and this one, so I will be left with this following equation. Which condition we are going to build on this equation in order to make this equation? It's impossible, because we cannot have left and right hand this equation with different pairs. Okay, so if this one, if x is super equal to 2, not 1, because if x equals 1 here, it will have number 1 here. We'll be left with odd integer, so which is okay. Okay, but if x is super equal to 2, this one becomes even, but this one is an odd, which is impossible. Okay, so which means we have no solution for this equation on this interval when we have x is super equal to 2, which means x must be inferior to number 1. Okay, let's check the positive integers first. So if x equals 0, we are not going to replace x equals 0 here, because this equation built on this condition when we have x is super equal to 1. Okay, we cannot replace x equals 0 here. We are going to take this value of x and insert it back into the original equation. Okay, I get e to the 0, which is 1. I get 2 to the 0, which is 1. So I get 1 minus 1 is 0 over 0, which is impossible. So we have no solution for this one. Let's check when we have x equals 1. If x equals 1, this one holds, because if x equals 1, this one turns into number 1. So we get the left hand side of this equation and the right hand of this equation both odd, which is okay. So also replacing x with number 1, I get here 2 to the 1, which is 1. I get 2 to the 1, which is 2. 2 plus 1, which is 3. So also, if you replace x with number 3 on the right hand side of this equation, I get number 3 here also, which this equation is satisfied this solution. Okay, so you can check this x equals 1 in either equation, this one or this one. You will have a solution. Okay, so what about now we get this solution? What about if x is strictly inferior than 0? In this final step, we are going to show this equation doesn't accept any solution when you have x is strictly inferior than 0. Okay, so previously the only solution that we found only one solution for this equation at the x equals 1. So now simply we are going to consider a set x equals minus a, where is a is super equal to number 1, because we already checked when we have x equals 0 have no solution. So we are going to consider when we have a is super equal to 1, which is x is strictly inferior than number 1. Okay, so because we are taking the negative numbers, so now we are going to take the inverse of these things. So by replacing x with minus a, I get the following. I get a to the minus a minus 2 to the minus a all over 6 to the minus a minus 3 to the minus a, which equals number 2. Okay, so I'm simply going to take 2 to the minus a as a common factor here. So I'll have the following. I'll get 2 to the minus a factor 2 to the minus 2 to the a minus number 1. So how I get to this one? So you know 8 is the same as 2 to the 3a. Okay, so it becomes with this inverse minus, with this minus sign, it becomes minus 2a. So by taking one of the 2 to minus a outside of these things, it becomes this one. If you multiply this one by this one, it will take you to the original things here. The same thing with denominator. So I'm going to take 3 to the minus a as a common factor as well here. So we'll have the following. I get 3 to the minus a factor 2 to the minus a minus number 1, like this, which equals number 2. So as you know, this one, it becomes 2 to the minus a minus 1 factor 2 to the minus a plus number 1. So because I have a difference of two squares. Then cancelling one of these 2 to the minus number 1 from denominator, I will be left with the following. So I get 2 over 3, all a is raised to the minus a is multiplied by 2 to the minus a plus number 1, which equals number 2. So instead to have 2 over 3, I will have 3 over 2 to the a. Okay, so this one equivalent 3 over 2, all is raised to the a as an exponent is multiplied. This one also becomes 1 over 2 to the a plus number 1, which equals number 2, like this. I'm going to put this number 2 inside of this one by simplifying this equation more. So I will have the following. I have 3 to the a factor, I will have 1 plus 2 to the a all over, I will have the common denominator 2 to the a. By multiplying these things here, 2 to the a becomes 2 to the 2 to a, becomes 2 to the 2a, which equals number 2. So now at this moment, I'm going to multiply both sides of this equation by this number, 2 to the 2a. So we'll have the following. I will have 3 to the a factor 1 plus 2 to the a, which equals, by crossing the multiplication and bring this one to the other side of this equation, I will have 2 to the 2a plus number 1, because I have number 2 here will be added on the exponent here. Okay, so I will have 2 to the 2a plus number 1. Okay, so I'm simply here, I have ended with this nice expression here. If you take a look carefully at this equation, we get the left hand side of this equation is odd, because this one is odd, is multiplied by odd, but the right hand side of this equation is even, since you have a is superior equal to 1. Okay, so we can apply modulo arithmetic on this one. So we know this one is reduced to the mat 3. I'm going to reduce both sides of this equation to the mat 3. So I get this one, since I have 3 to the a as a common factor here, so this one becomes 0. So we'll have the following. this one becomes minus 1 is raised to the 2a plus number 1 as an exponent, which is congruent to 0 mod 3. Okay, you might say how I get to this one here. I simply replace it 2 with 3 minus number 1. 3 will be 0 as you reduce the equation to the mod 3. I will be left with minus 1 all is raised to the 2a plus number 1 as an exponent. You know this term is odd. 2a plus number 1 is odd, which means my expression becomes, you know, the exponent is odd because it's written on the form of the odd expression 2a plus number 1. So I'm going to take off this exponent. I will be left with minus number 1, which is congruent to minus 1 plus number 3. Just I'm adding number 3, okay, because it's divisible by number 3. So if I'm going to calculate this one, is congruent to 2. You know the right hand side of this equation is congruent to 0. To 0 mod 3. According to the divisibility statement, this one is starting as 3 divides number 2, which clearly it's impossible. Okay, I have shown we have no solutions for this equation when we have x is a negative, we have x greater than 0. So we have proven all the cases. We found only the solution for this equation, which it was x equals number 1. Okay, so we have ended this video. By the way, don't forget to hit the subscribe button and support the channel, and thank you for watching. I will see you next video. Bye.